Okay, so good morning everybody. I'm Stefano Mariani, one of the two teachers for this course. You already met Professor Stefania Monica, right? I guess she already introduced you to this course, at least a bit of an overview, the logistics, whatever. So maybe some of this information is duplicated. But most of this information is specific to my part of the course, which is the data science part. So contrary to last year, in which, and you will notice if you check the video recordings of the lessons, in which we did first the artificial intelligence part and then the data science part. This year we mixed. For a few reasons. One of which is, let's see what happens, basically. So first 2 years that we together do the course, so let's see what happens. And one is most practical. This is not a programming course, at least in my part, but to not let the course be only theoretical, we need to do some practice. So we will use a reference programming language, we will use some computer science tools, and the programming language of choice will be Python. And I need to make sure that, not that all of you are programmers, we don't need that, but at the very least that all of you understand a bit of Python. Okay, that's more or less the go-to tool for not only data science, but machine learning, artificial intelligence. I know there is also R. Maybe some of you are familiar with this language and framework called R, which is probably more used than Python in data science, but only for data science. Okay, instead of Python. It is also valuable for general artificial intelligence and other topics. So, one reason to mix up the two parts of the course is that in the first lesson we will do an overview of Python. Okay, because I must be sure that all of you have at least a minimal grasp, okay, of the Python language, how to write simple snippets of code and stuff like that. So obviously this is also to tell you that if you already know how to program in Python, you can probably skip the first lessons, okay? Attendance is not mandatory, so you can probably skip them. We will have some specific deep dives on libraries specific to data science, such as, for instance, NumPy, Pandas, maybe scikit-learn, something like that. As I said, the purpose is not to make you programmers. The purpose is to show you that the concepts that we see in theory have a practical correspondence, okay? And how to quickly prototype a data visualization pipeline, a machine learning pipeline, some exploratory data analysis, okay? So that you can at least pick the right tools from the internet, that's fine, and glue them together. Okay, in a script. That's the purpose. So, the artificial intelligence course, part of the course has been already described, I guess. As far as instead the data science part is concerned, this will be basically an overview course. We will not go vertically into some topics, so you will not become expert in any of these topics. You will get, let's say, a quick guide, okay, about most of the topics that are relevant to data science. It is impossible to cover all the topics in alpha course, in 6 credits, basically. So that if you need to deep dive into one of these topics, at least you know the basic terminology, you know what to look for, okay, you already have some foundations. So that's the purpose of this half of the course. So let's say that after the course you will do an internship or a thesis or apply for some positions, or you need to strengthen your knowledge on some topics related to the one of the course. You now, after the course, you now know where to look for, what is the basic terminology, okay, stuff like that. So we will start with an introduction, okay, basically what is data science, a very quick background of statistics. If you want to be an expert data scientist, you need to have a much more solid background on statistics, okay. I would say that's the most difficult thing in data science, is having a solid background in statistics. We will mention best practices for data visualization and exploration, which is a big part in data science, obviously, presenting the data in the most optimal way. Then I would say that the big deal of the course will be an overview of different machine learning techniques. Okay, this is a big part, again, in data science. We will try to do as many practical examples as we can, again, at the price of not fully understanding every detail of the code that we will look at. If we have enough time, last year we had time to touch reinforcement learning, which is a topic I care about, which is because it is one of my research topics, and also because it is one of the bridges between the two parts of the course, so between artificial intelligence and data science. And last year we didn't. Let's see this year if we manage to. We could also touch LLMs, okay, large language models, generative AI, whatever the name you understood. Okay, ChatGPT and friends, basically. Okay. If we manage. I know that perhaps not this, but this is a huge topic at the moment. Maybe if you're looking at job positions somewhere, it is all about generative AI. I agree that it's an important topic, but we can't squeeze everything in this course. Okay, so I have to make some choice. And basically my choice is that all of this is necessary, this is not, this is interesting and fun, this is boring. So I am the teacher, go with it, okay? Basically. So all the lectures will be in class, there is no lab, because the class is the lab, okay? You don't need to bring your own laptop if you don't, okay? Oftentimes I encourage you not to bring your laptop, just because otherwise when we do coding, we will do very little coding, and most of the coding will not be live, apart from these very few lessons, so you don't really need to bring the laptop. And the risk is also that when I speak you don't understand, but you try to copy what I say. So you can also take notes with paper and pen in the good old way. All the course material is already on the Moodle website. This is the Moodle website, and you must know it, because that's the main source of information for the course. Okay, so if you don't know, there is a website called Moodle Unimore IT. Who is the first time that hears about this website? Okay, so go to Moodle Unimore IT. Okay, you have to navigate a bit. So in the landing page, I guess that you have, I don't know if you already have to log in with your Unimore credentials, but at some point you are presented with a list of the departments. So this course belongs to the Digital Automation Engineering master degree offered by the DSME, Department of Science and Methods of Engineering. Then it is the master degree in Digital Automation Engineering, first semester, and then you find, hopefully sooner or later, you will find the course of Artificial Intelligence and Data Science. You need to explicitly subscribe to this forum, okay? You are not automatically subscribed, like for instance in the Microsoft Teams virtual classroom. that I think you are automatically subscribed to, but I won't use it, basically. Why it is important, this site? For a few reasons. The lesson schedule, so the full calendar will be online, but this is where we put all the updates. For instance, I don't know, maybe some lessons will be cancelled due to some reasons that we cannot control, stuff like that. So here you will find the updates. Here you will find information about the exam, so when you can take the exam, how to register to the exam, stuff like that. You can see now this, but soon it will appear. And basically the reference material for the course, so how the project works, exemplary questions for my interview exam, and the slides, exercises, both for Professor Monica and both for me. So for instance, in my section you can find a repository with all the code examples that we will see, a Google Colab for the overview that we will start, link to the recordings of the lectures, okay, the video recordings. Obviously now it's empty, but you have those of the last year. So if you cannot attend the lessons, you cannot follow the pace of the course, that's no problem. You have all the lessons on YouTube for the last year. There may be some small deviations, obviously. I don't follow a script when I talk to you, but the contents will be the same, perhaps with the only difference of reinforcement learning and LLMs at the end of the course. The rest of the contents are exactly the same, and all the slides. Okay, so basically whatever you need is here. Most important reason to subscribe to the forum is that I don't live here. I come by train, and so if the train explodes with me in the train, I will try to notify before the explosion. Okay, so I'm sorry guys, today the lesson will start 1 hour late. Sorry guys, today the lesson is cancelled. This is how I will inform you. If I remember, I will also inform you via the Microsoft Teams platform, but I don't guarantee that I remember to do that. Okay. Yeah, usually in this semester we will have lessons always on the Thursday. We divide it this way. There is a small deviation tomorrow. Tomorrow I will be here for the first 2 hours. Otherwise, we will meet every Thursday. And here is simply a link to the Moodle website that I showed you. I don't have fixed office hours because apart from the teaching duties, I don't have a fixed schedule where I come to the office. If you need everything, just write to me an email. I don't remember if I put my email address, but yeah, it's the same address of any other teacher at Unimore. So ask for an appointment anywhere, anytime. We can meet in presence, we can meet remotely, as you prefer. If you have quick questions, you obviously can make them via mail. As I said, subscribe to the Moodle website. I will try to upload the video recordings, let's say at most the day after our lesson. I won't always be able to do this, but I will try. Any questions up to now about the organization? If you have questions, raise your hand anytime. How is the exam? You have to take 2 exams, basically, okay, 1 for each part. They are completely independent, so different dates, different schedules, whatever. The only connection point is that you need to do a project. We will talk about the project that usually is a source of headaches for you at the beginning, then I clarify, and then, okay, everything is fine. So, 2 tests, 1 for the AI part that I don't know anything about, so ask Professor Monica for that. So in general, different dates. We will announce the dates and also handle the registration through Moodle, not through the S3 platform, as you probably are used to. This is more convenient for us. So you will do everything through Moodle, and then we will register your grades on S3. Each of the two tests has a score between obviously 18 and 30, with Laude if we deem so. The final score is the arithmetic average, so the same weight, okay, that you pass the exam. Both must be sufficient. You cannot average an insufficient grade. Before registering for an interview, or better, before showing up for the interview part of the exam, you need to submit a project. A small project that you do individually, so we don't allow group projects by rule. If you want to do a group project, you have to motivate and we have to agree, okay, that you can do the project as a group. Otherwise, it's individual. The project must be, first of all, agreed with both of us, with both me and Professor Monica. So the rule is, when you want to start thinking about the exam or the project, write a mail with both of us, okay, as recipients, informing us, I wish to do the project on this topic and a preliminary plan, okay? So for instance, I want to apply machine learning to predict stock prices, okay, because I want to become rich with low effort. So I will take these data sets, I will apply these methods, I will evaluate my models in this way, a preliminary plan, a sort of work plan. Then you can deviate it from the work plan, there's nothing wrong, okay? But you must submit a proposal, okay, a work plan. 1 page, 2 pages, nothing really big. The project remains valid for an academic year, so when I say you have to submit the project, we ask you to submit the project at least a few days, 2 or 3 days before the interview exam you registered to, so we have enough time to check the project and say, okay, come to the interview or not. The project is just, does not award any grade, okay? The project is just, okay, you did the project, you can come to the interview. And usually, at least in my part, again, for Professor Monica part, ask it there, but for my part, usually the project is the starting point for your interview. So typically, the first questions will be like, okay, you did it this way, what other way you have to do, how do you did it this way, why not using this other technique, stuff like that. There is also a document on the website describing the project, providing you some ideas. So, what to say more about the project? So, you can choose one or more topics from the course, whatever topic you want. You don't need with the project to cover both parts of the course. You can choose a topic that is only data science, only machine learning, one that is only Professor Monica topic, it's fine. Okay, so you don't need to combine something that belongs to Professor Monica part of the lectures and one that belongs to mine. You can choose one or more. Discuss the project details in advance, as I said. Typically they are not made in groups, so motivate it if you need. The project is meant to be some practical problem. So in my part, for instance, it will be implementing a simple Python scripts that do something. Some data analysis, some data exploration, some data visualization, some model training, whatever. As I said, there are no marks, there are no grades. It is a yes/no to go to the exam. Last 2 points. Yes, if you want, you can use any kind of AI-assisted tool for programming, it's fine. You want to pay the programming with ChatGPT course or GitHub Copilot, whatever, I don't care. This is not a programming course, so I don't care if you don't know the fundamentals of programming. If you can assemble a reasonable project and you know what you're doing in the project, okay, I chose this model because I don't care if you are not using the model, the functions of the scikit-learn library in the best way possible. I don't care at all, okay? But I am using this model because I am doing this test because that's what I care about, okay, during the exam. So use whatever tool you want to speed up programming and to avoid having to deal with mundane details of programming, but don't copy the project from the web. And for my part of the project, I already say you from the beginning, this is very easy. Okay? If you want to do some projects about data science, usually what is the procedure? The easiest procedure, go to a website that is called kaggle.com. Okay? How many of you already heard about Kaggle? Kaggle. Okay, you. So all of you now can cheat because I disclosed this information, but there is this website that is very useful because it is a website that gathers together dataset, publicly usable, okay, free to use. And for every dataset, there are also usually a lot of examples of data analysis, data exploration, machine learning tutorials, programmed usually in Python, made available to you. Okay, so basically you want to go there, pick a dataset, look for the tutorial that he likes the most, and give the tutorial to me. Okay, don't do that. What you can do is go to Kaggle, find a dataset that interests you, basketball players, diagnostics, satellites, whatever you are interested in, games, whatever. Pick a dataset, look at the tutorials, look what they are doing, find a tutorial that you like, and change something. Propose your own version. Okay, that's perfectly fine. So, for instance, when you describe the project, even when you propose the project, I will ask you, okay, what dataset do you plan to use? Where does it come from? Is it from Kaggle or from another similar platform? Okay, tell me what are the tutorials that you are getting inspiration from. That's fine. Okay, and you don't need to completely change the tutorial. Just show me that you know what you are doing. That's it. The interview will be in English, obviously, as the course. More or less, it will be a quick interview, so 20 minutes, half an hour, stuff like that. And it will cover all the topics of the course. So, if we touch some topic that for whatever reason I deem that it is not necessary to cover during the exam, I will explicitly tell you. So, otherwise, every topic that we talk about is part of the exam, potentially part of the exam. And this includes some practice. So, how would you create a pipeline for training a decision tree? I don't care that you remember the Python instructions, okay? I just want you to sketch what the code may look like, okay? Even using fictitious functions names, fictitious data classes, I don't care, okay? But for practice, that's what I mean, okay? Just sketch what you will need to do. Well, first I prepare the data set, then I do some data cleaning, then I do model training, I repeat model training n times, stuff like that. For the interview, you usually you have to bring along your project. So, as I said, usually it's the starting point. Yes. So not only during the interview, but even when you propose your project, clearly state your goal and disclose the dataset you're using, where you pick it from, and whatever. We will use Python, as I said. Is available for any platform. It is available even for tablets, stuff like that. You are free to use whatever programming tool you want. I will use PyCharm or Jupyter, which is PyCharm is a sort of text editor on steroids for programming, and Jupyter is, or Google Colab, as we will see, another, let's say, text editor on steroids that usually makes it easier to share code between developers. There is not really a reference book for the course because the course is assembled from many disparate sources, other courses, papers, whatever. But if you want a book, for any reason, among the plethora of books available on the topic, I think that this is well made. It has frequent bridges between theory and practice, and it is completely free. So why not using a free book? Okay. I don't. The only thing I don't remember if you can download a PDF version, but I think so. Anyway, if this is not what you're looking for, just send me an email and I will find what suits your need. Okay, questions about the organization? I guess I told you everything. So before starting with the first introduction, it may make sense to quickly introduce also me. Also because that will be the chance for you to introduce you. Maybe not one by one, but at least to know, for me to know something about you. So, I am a computer scientist and engineer, so I'm not a management engineer, mechatronics engineer, whatever. I studied at the University of Bologna in the Cesena campus long ago, and I graduated in computer science and engineering, and I have a PhD in computer science and engineering also from the University of Bologna. Then I would say 2016 maybe, so more or less 10 years ago, I came here to do research, and my research topics at the time were about having a distributed systems and system, so multiple computers, multiple software connected together via the network. And my interest was in finding the best ways to let all these different computers, all these different networked pieces of software collaborate together for a common goal, for a shared goal. Then, as I said, in 2016 I came here to work on a European project. I came here because I really like Reggio Emilia. No, I came here because here there were the money. Okay, so as usually when you move away is because the money is there. And this research project had nothing to do with my research interests. Okay, the research project was basically an healthcare project about delivering what is called personalized treatments, personalized medicine, stuff like that. Why they needed computer scientists? Because even 10 years ago, artificial intelligence was a big topic everywhere, and everybody wanted to use artificial intelligence to improve something. So, in this project, it was the very first time, 10 years ago, that I started studying data science, machine learning, and these related topics. Okay, because I needed to, for instance, look into patient data and try to understand whether a patient that had chronic diseases, for instance, chronic pulmonary diseases like asthma or stuff like that, my task was to try to use the patient data to predict what was the chance that a given patient developed an acute episode of one of these chronic diseases in the next month, 3 months, 6 months, whatever. Okay. This was, for instance, one of the tasks that I had to deliver. So then the project ended and everything was fine, and I more or less came back to my usual research interest, but trying to combine my previous interest, so about coordinating these pieces of software, with machine learning. So I learned about machine learning for 3 years at the time, and I didn't want to throw away all that knowledge, but I wanted to reuse that knowledge. So now I would say that my research interests are unchanged in the goal. So find the best way for a group of, we call them agents. So probably this word agent will also be used in the artificial intelligence part of the course. So these distributed software pieces, how to find the best way for them to collaborate, but now one viable option to find this best way is to let the agents learn how to do so. So I don't want to think about the best way for them to coordinate and then program the software to coordinate. I want to think at how then can learn on themselves how to best collaborate, and then they figure out themselves what to do. So the goal is the same, but the way to get there is changing. So here is my website that is linked, I don't know, somewhere, hopefully. Why it may matter to you, just because if you are interested in some of the activities we will cover, you can find out more on what are the research topics that usually I propose as a thesis or internships or whatever. Okay, so if you want to do an internship, if you want to do a thesis, if you want to, or simply if you want some guidance or about these topics, just send me an email. And basically that's it. I'm here since, as I said, 2016. Since then I teach another course in the bachelor degree in management engineering. The course is Fundamentals of Programming. Originally it was in Java, now since a few years, maybe 5, I don't know, it's in Python. And then since last year I teach also this course. And I co-teach another course, but in Modena, in the Artificial Intelligence Master Degree in Modena, that is about distributed artificial intelligence. And what else? Well, I guess you don't really care about anything else. I like dinosaurs, basketball, so if you want to bring me a project about dinosaurs and basketball, usually the project is okay. What else? Basketball, dinosaurs, music, but only good music. Yeah, that's it. Okay. Okay, so a bit of an introduction. Oh no, before the introduction. So I have a couple of questions instead for you. So for instance, who graduated here in Reggio Emilia in one of the degree courses here in Reggio Emilia? Okay, raise your hands. More or less half of you. Okay. Management engineering. Okay. Not management engineering. Something like mechatronics. Everyone mechatronics or something else? What? Don't be shy, yeah?
I'm oriented from international studies in
Yeah.
Argentina.
Okay.
And I'm doing a master degree on business and data analytics.
Okay, so this is an exam of your choice, right? Okay. Anyone else that is not graduated in one of these two degrees that I mentioned, mechatronics and management? Okay. How many of you already has experiences in programming? Not with Python. Programming, whatever language. Experiences may be, I wrote a program that printed Hello World to the console. That's fine. Okay. So, okay, most of you know the fundamentals of programming. In Python, half, the other half, C++, all the mechatronics, I guess, C++. That's the only language you see in mechatronics, right? Okay. Well, to some extent, Python is easier than C++. So you should not have a hard time. Who has no experience whatsoever with programming? I heard about programming. I never wrote a single line of code. Well, okay, that's good. So maybe this year, this Python leveling part will be easy. Let me see if I have some other questions. Okay, why did you enroll in this? This is a very difficult question. Why do you enroll in this course? What do you do when you are old like me? Do you want to do data analyst? Do you want to do programming? Do you want to do business consulting? So, what do you want to do? One reply could be, I have no idea, but I will try to find out during these 2 years. So, who has an idea, any idea of what to do when he graduates? You seem quite convinced, no?
Not this type of jobs.
Okay.
Design for sure, like R&D in mechatronics.
Okay, so
still studying mechatronics, I chose this
as an exam of choice, okay. So building things, okay, right? Building things, building automation, stuff like that. Robots are fancy. Whoever has some idea of what to do? Nobody, it's fine. I mean, during my PhD, I still had no idea if we wanted to do this or if I want to do and dig up dinosaurs' bones. So it's fine. It's fine. Okay, let's hope that you find out in these 2 years. This is your first year. Yeah. Okay, so let's try to understand what is data science. Have you ever heard about data science? Heard maybe yes, but no courses about data science, data exploration, machine learning, no whatever. More or less. Something. Did you mention something in mechatronics about learning, machine learning, data science? No. Okay. So data science is very easy to define. It is the application of computational and statistical techniques, and this is very important, to address problems or to gain insights in problems. Problems that hopefully belong to the real world. Okay? This is something that sometimes we forgot, but usually we want to solve problems that belong to the real world. You can find many definitions of data science online, but this is one that I particularly appreciate. Data science was more or less what nowadays is generative AI, I don't know, maybe 10 years ago. So it was all about data science. Every future job will be a job in data science and whatever. And why was that so and still is like this? It's because as 10, maybe even 15, but I would say 30 years since the inception of since the explosion of the World Wide Web, basically every company, every individual, every public organization, everyone on the world is drowning in data. Okay, we are producing lots of data. Everyone, corporates, private people, public organization, whoever is producing far more data than it can analyze. Okay, this is true no matter what. This is a matter of fact. So, for companies especially, it is particularly interesting to try to make sense of all this data. Okay? So, one typical request that you have when you land your first job in a semi-small business in the area is, look, we are looking for a data scientist because it is 10 years that we keep track of all this data, how our inventory management systems, we track all the expenses, we track everything that happens in the company, and we want to use this data to improve. To improve what? Usually revenues, if you're talking about companies, okay? And so usually, your first task as a data scientist is, okay, let's try to understand how we can use the data to achieve some goal. Increase revenues, increase reputation of the firm, or whatever, okay? So this is just a slide that tells you, it is also outdated, but who cares? Simply these numbers are much higher now. So every minute, every day, okay, there are 1.7 billion pieces of content on Facebook, more than 300,000 tweets on Twitter, or I should say X, probably even more. Okay, not probably. For sure, even more, since now most of this content is AI generated, so it's very easy to generate content. Crypto exchanges, email messages, 231 million of messages every minute, every day. Okay. And so, yes, I would say 20 years ago, even more, people acknowledged that the skill of knowing how to use data for one's own advantage is crucial. Okay? So that's the main motivation for studying data science. We need to make sense of the data. And I would argue that another motivation is, let's say you don't care so much about data science, okay, like your colleagues here. It's perfectly fine. But I would argue that it is beneficial to you if you know a bit how the people that present to you some graph, okay, built that graph. Because I don't know if I put the quote on the slides, but one danger of data science is that if you torture your data enough, okay, data will confess anything. So we can take the exact same data, as it is common in politics, for instance. I hope that you don't watch political debates on the TV, but if you do, you already know that the same data can be delivered in many different ways. Okay. So, what are the skills that an ideal data science should have? Well, I have bad news for you. It is not so easy to become a data scientist. Because ideally, you need to have many skills. You need for sure to have skills in math and statistics. And this is most of the time the most difficult thing to have. Because taking a Python library, okay, a Python package, and using the package to do some machine learning pipeline, to create some machine learning pipeline, is fairly easy. But understanding whether what you are doing does make any sense is not so easy, okay? And that's what this knowledge comes from, okay? From your foundations of mathematics and statistics. So for instance, knowing, okay, my prediction is that stock prices will increase. Fine. How can I be confident in that prediction? How it is probable that the prediction is wrong? To answer the questions, you need to have some foundation about math and statistics. Furthermore, most, I would say almost all of the machine learning techniques that we will see are based on statistical concepts. Then usually you need to have some background about programming and maybe also database systems. Because when you're dealing with data, with some of these methods, okay, usually you have to use tools that give you these methods in practice. So you need programming libraries that implemented this specific statistical model, this specific machine learning model, or whatever. And you need to do so by taking data from somewhere. And usually this data is stored in a database. These, I would say, are the, let's say, hard skills, okay? If you want to actually be the one that finds the value in data, you need to have these hard skills. But then, once you have your perfect machine learning model that predicts, for instance, when a robot or a machine will fail, okay? This is very relevant. Let's think about a production plant, okay, that has to produce some finite product or whatever. predicting when a machine, one of your equipments, is about to break is crucial. Because usually the downtime of the machine for recovery from a break, or the downtime of the machine to do maintenance, to avoid the break, they are not compared. Okay, maintenance is far more fast than recovering. Then, in that case, you have a perfect model, but now you need to convince your management that they need to fund your activity, to bring this model in production, to rely on that model to do the prediction. Otherwise, the management will say to you, why do I have to stop a machine that is functioning perfectly fine, so lose my production pace just because one of your models is telling me that the probability that the equipment will fail within the next week are 80%. I mean, you need to convince me, okay? So in that case, you will need communication and visualization skills. You need to communicate why your model is doing good, why your model will bring value to the company. You need to communicate, look, I found a bottleneck in the way we handle invoices or inventory management or whatever. You need to communicate that bottleneck. Don't expect to go to management in the general case, show them Python code or a bunch of numbers. They want to see pictures, okay? Not because they are stupid, because they don't know the details and they don't want to know the details, the technical details, okay? They want to know the message. So this is a very important skill, okay? There are some plots. Every time you do a plot, the plot should speak 1,000 words. I must look at the plot, one sentence, my model is able to deliver this insight. Ah, yes, it's true. It must be almost immediate. If I have to think about the plot, if I have to study all the details of the plot, probably that's not the best plot, okay? And then obviously, one thing that is oftentimes disregarded, what I would say is, probably the most important thing when you want to get to the real world, and one of the things I had to do when I embarked on the research project I told you before, is, well, at least you should know something about the business domain, okay, the scenarios where you are applying these techniques. A quick example is, for instance, in healthcare, usually doctors don't care if your model is a beast. Every prediction of your model is okay if they have no idea about why the model made that prediction. Why is that the case? Because they have the final responsibility of assigning to a patient a specific treatment, not the machine, the people. So for instance, they don't care if your brand new neural network architecture outperforms all of the state of art in predicting, in diagnosing cancer. If there is no way to have any clue about why the model is doing that prediction, usually doctors won't use that model. They prefer a model that has less accuracy, but they can understand why the model is doing that prediction. Okay. And this is maybe different, for instance, instead in, as I said, machinery maintenance. If the model is fine, let's do the maintenance on the machinery. In the very worst case, I'm doing the maintenance 1 week before the scheduled maintenance. Who cares? Okay. So usually, if you embark in some data science related job, usually either you become a domain expert or you work in close relationship with domain experts. So for instance, my first 6-9 months of the European project was working with doctors and trying to understand each other, basically. That's it. And when you ask data, they give you some papers to print out with text in it. And that's not what you originally intended with data. You had in mind a database, all the rows are fine, all the columns are fine, everything is clean. That's not how usually the real world works. Okay? So we will obviously, in this course, we will not cover domain knowledge. We will briefly cover visualization skills. We will not cover database technology, a bit of programming, and we will mostly cover the theory behind statistical and machine learning techniques. By theory, I do not intend the formalization, the mathematical formalization of the algorithms, but the main intuitions behind these different techniques. So basically, given some data and a problem to address, for instance, increase the revenues, your task as a data scientist usually is choose a model that solves the problem, okay? And usually solving the problems amounts to do something for which you have many alternatives, okay? If I want to convince my business people that, I don't know, we should redesign the layout of our inventory, okay? Because some data shows that we have a bottleneck in moving some objects. Probably there are plenty of ways in which I can try to convince the management. Plenty of plots, plenty of analysis on, I don't know, the time spent by the personnel in looking for items, stuff like that. Anytime I have to choose one model to deliver a message, there is the problem of how can I define the best model for doing that job, for achieving that goal. So usually you should define some evaluation metric, and obviously your goal becomes to choose the model that maximizes that performance metric. So I want the model that minimizes downtime of the machinery when I'm doing maintenance. That is a reasonable goal. Okay. I want a model that maximizes revenues. I want a model that minimizes the distance traveled by the personnel when retrieving objects from the inventory. Okay. So, for instance, even inventory placement. So, I want to place objects on the shelves of my inventory, of my warehouse, in a way that it is the easiest possible for people or robots to pick the different objects. Okay. So, usually you have these are the ingredients, let's say, of a data science activity. You have a problem. You have some data. The problem is your goal, basically. Okay? You have some data, and then you have a portfolio of techniques to use. And what you want to do is define, first of all, some performance metric that you can choose, that you can use to choose one of the many goals that you have at your disposal. Okay. So, in order to do this evaluation, one very important role is that of experimentation and testing. Okay. So, you need to formulate an hypothesis. For me, if we place the snacks side by side on the shelves of a supermarket, side by side with beers, the same shelves, I guess we can increase the revenues for both. Okay, so don't put beers near wine, near water, near soda or Coca-Cola, whatever. Put the beers side by side the snacks. My guess is that we will increase the revenues. Is that true? You need to prove that it is true. So you need to do some experiments, you need to formulate an hypothesis, and you need to validate, to do testing and experimentation with what goal? Refute or validate your hypothesis. Okay. Is it true that by moving these objects together we will increase the revenues? Stuff like that. Okay. What are the examples of what you can do, or better, what are examples of data science problems? Almost everything is a data science problem. Well, for instance, establishing whether a given stock will raise, and so I should probably buy now, in the next few hours, in the next few days, whatever, that's a data science problem. And actually, stock trading is one of the oldest applications of data science, even before it was called data science. I don't know if you're aware of this, but nowadays, but in truth, since many years, most of the stock trading volume in the world is not done by humans, but it is done by algorithms. Okay, that's it. This is a very good movie. I don't know if you've seen it. It's about baseball, if I don't remember. It's about baseball. I don't understand baseball at all, but the movie is great. Yeah, it's the story of this guy that started suggesting bad teams, if I remember correctly, what players to sign to improve themselves. And obviously, at the time, I don't remember when it was historically placed in the film, maybe the 90s, I don't know. At that time, usually the decision about whether to hire a player or not, or which player to hire, was based on expertise. There were talent scouts, there were coaches, expert people. Yeah, he looks good, let's sign this player, okay. These guys that started applying data analysis, statistics, to the players' metrics, okay, to sign underrated players, basically. Okay? And that was a revolution. Nowadays, every sport, every team has a, let's say, data science team within the team that analyzes the statistics of the player, the coverage in a field, whatever. Okay? So that's a very interesting application. Customer profiling. This is also one of the oldest applications of data science. And every company that has customers can do this. Historically, telephone companies, internet providers, streaming services, stuff like that, historically they do this. So even ancient telephone companies, like if you're older than me, if you're old like me, you remember Telecom or whatever, even before the internet, they were doing customer profile. Okay? Something that unfortunately all of us, more or less, and sooner or later have to deal with, is getting a loan to buy a house or whatever. I mean, even if you know somebody that works in a bank and maybe can give you a hand, usually whether you can get a loan or not is determined by an algorithm, okay, that looks at your data, some data, that you didn't even know that the bank has about you, they look at some data and try to predict whether you will be able to reimburse their loan. Insurance companies, it's the same. Okay, so are you high risk? Are you low risk? As I said, basically any kind of company can find something to do with your data. So for instance, just to make you an even more practical example, one of the recent projects I was involved in was a project about CRIF, CRIF, which is basically a company that has a great power over our lives, because basically it's the company that gathers data about citizens, and not only citizens, also other companies, whatever, to establish whether you are financially good. So for instance, the banks ask to CRIF, look, should we give a loan to Stefano Mariani, yes or no? And CRIF as your data. And so in one of the projects I was involved, CRIF typically worked with banks, okay, so also given, they call this a credit score to companies. So if this company applies for some loan, should you give it the company the loan? Is it the company healthy from a financial and economic point of view? That's the kind of data that CRIF manages. In one of these projects, since they have lots of this data also for private citizens, they wanted to apply this data to try to assign people a renting score for renting apartments. So, are you a good people to rent my apartment to? Am I a good landowner? Okay. Do I take care of the apartment, stuff like that? So that's another application in which obviously making sense of all these different sources of data is useful. Another, when or where should we perform some maintenance? This idea of predictive maintenance is since a few years that is a very hot topic. Whenever you have some equipment, so you are producing something, or equipment could be, even if you are a logistics company, your vehicles, okay, it's basically the same. Whenever you have some machinery, the not so good old way of doing maintenance was reactive maintenance. When the machinery breaks, we recover the machine. That's not very smart, because obviously you impact your production schedule. Usually when a machine breaks, you didn't anticipate that the machine will break, so you are not ready. So we transitioned to planned maintenance. Okay, let's do maintenance every 3 months. Why? Because that guy works here since 50 years, so he knows, okay, this was the not so good old way. Now you can say, let's do scheduled maintenance, because looking at the past, we have seen that more or less every 2 months, the machinery has some issues. So let's schedule maintenance every 2 months. Proactive, okay? Let's try to minimize the risk of a machinery breaking. That's another way related to maintenance. Now, the best way would be predictive maintenance. Okay? Let's try to find out whether there are any indicators that tell me that the machine is about to break or needs maintenance because it is degrading performance. Okay? This can be quite easy to do. Okay? For instance, if you work with mobile robots, for instance, that have wheels or stuff like that to move, from time to time, wheels lose their calibration. So if you tell the robot to go straight, like in a car, the robot maybe tends to go a little left, a little right, okay? It's because of the tires that are wearing out, it's because of the calibration of the steering wheel, many reasons. You can detect that. You can easily detect through sensor when the robot is deviating from an ideal trajectory and trying to do predictive maintenance. For instance, when this deviation exceeds a given threshold. Okay. Obviously, it is easier said than done, but you can do this. Lead time prediction. For the management engineers here, I think they know better than me what lead time prediction is and why it is so important for companies, but lead time prediction is a typical application of machine learning. Okay. Let's try to predict in this situation, these machineries are working, we have this logistics department working in that way, this is our fleet of vehicles, whatever. Let's try to predict how frequently we can deliver items to our customers. Okay. This is very important. In general, obviously, the goal of every company is how can we improve the production by doing what? Okay, that's obviously the general question. Okay. In healthcare, so can we, beyond any reasonable doubts, assess that this gene causes that pathology? And this is subtly different from, also here, this is subtly different from the kind of machine learning we talked up to now. This involves understanding the causes of some effects. We will put some emphasis on this later on. But these are all applications of data science. This is not an exhaustive list, but I guess that whatever goal, task, or company, or data you can think about, you can figure out an application of data science. How can Spotify suggest you the next song to listen to? I don't know because I don't have Spotify, but they have some algorithm that looks at what you're doing. Probably they do customer profiling. So what are listening to other people that listen to your same songs, more or less? One of the pioneering company in doing this sort of, they are called recommendation in technical terms. When I suggest you something, that's a recommendation. One of the pioneering companies that is doing this, I would say since its inception, and it was what sets it apart from the competitors at the time, and that it is still doing it, probably with more sophisticated techniques, is Amazon. There is one incredibly simple feature in Amazon that is in Amazon since its very beginning. Customers who bought this bought also that. This is an extremely simple idea. One of those ideas that after you heard about the idea, you tell yourself, oh, I could come up with that too, but you didn't. This is there since the very beginning of Amazon. If you look to one of those websites, one is called the Wayback Machine, is a website that registers websites in time. So you can find, for instance, how the Amazon website looked like in the 90s. That feature was there. That was extremely simple because it worked simply by counting frequencies, okay? And we will do, I guess at the end of the course, we will see what are the techniques behind that. They are called association rules mining. They were simply counting occurrences in which two or more items appear together in the shopping cart. Very simple idea, extremely effective. Okay, so one thing that is very difficult to do and we won't attempt to do, there will be only this slide about this and that's it. And one of the reasons because it does make sense to have one course about data science and artificial intelligence, even if they may seem different topics, is trying to answer this question, where we can draw a line between data science and AI. AI is huge. So let's focus on machine learning. It's very difficult. It's very difficult to draw a crisp line between the two. Okay. Maybe I can say that if your task is to do data visualization, okay, you are mostly on the data science side. If you are creating an algorithm for a novel predictor in supervised learning, okay, probably you are mostly on the machine learning side. But you are very well mixed, because if you are creating a novel algorithm, sooner or later you will have to test that algorithm. And to test that algorithm, you need to handle data somehow. And you need to show the results of your algorithm. So the line is very blurred. AI, obviously, is a term that I strongly encourage you, whenever somebody comes to you and tell you, look, I have a new idea for an AI application, for an AI algorithm. AI is like computer science, is everything. Okay, it doesn't mean nothing. Okay, there are many branches of artificial intelligence, many subfields. Nowadays, artificial intelligence is mostly equal to generative AI. That's not true. A few years ago, mostly artificial intelligence was equal to machine learning, and that was also not true. But that's fine for the, let's say, for the normal people. That's fine. Artificial intelligence is also many other things that Professor Monica will tell you about. Search algorithms, software abstractions, stuff like that. So, if we try our best to put a line, let's say that data science is mostly concerned with extracting insights from data. So, I have some data, I want to summarize this data into a usable information. As I said, sometimes some of my PhD students or my research collaborator come to me, write to me an email. Look, I did the experiment that we were talking about, it's working great. See the attached file. And the attached file is, I don't know, a CSV file or a table of a database. That's not really an insight. That's the raw data of your experiment. I mean, how am I supposed to look at the raw data and in 10 minutes tell you, okay, it's great or not? No. Data science is taking the raw data and extract information, something that has value. So in this sense, data science is strictly related to business. There should be value in the insights you are providing. More revenues, less expenditure, healthy patients, whatever you want, but there should be value. Strictly speaking, instead, machine learning is the science of teaching machines to accomplish tasks. That's it. As the name suggests, machine learning means let's come up with techniques to have a software learn by itself how to achieve a given goal. That's machine. Obviously, you can use this to do data science. Let's teach a machine to extract insights from data. That's why they are related. And you can use data science for machine learning. The better the data and the more informative the data I give to the machine, the better the machine can learn to achieve the task. So that's why machine learning and data science are strictly related. Okay? We don't really mind this distinction, okay? It's just to at least try to define a bit better the terminology. So data science is not a subfield of machine learning is not a subfield of data science. They are different fields, okay? And they have intersections. One thing that is actually, as I said, the main lesson that I hope you will take away from this course is the bottom line, that doing data science requires critical thinking. Right? Many people approach data science like this. Okay, cool. Professor Mariani told us that about this awesome Python library that can create for me a machine learning model to do these awesome predictions that achieve 90% accuracy in this task. Usually, so what I need to do now is I get data, I throw this data into a computer, into this algorithm, and I get insights. Usually that's not how it works. As I said, you took data, you take the data, you put the data into a prediction algorithm, you get a prediction. You evaluate the predictions, 90% of the time you are correct. Is the model a good model? I don't know. I need more information. Why 90% of the time it's correct? It can be pure chance. Okay? So that's why critical thinking is important. You cannot do this. Okay? You do not throw data into a computer and expect the computer to understand things. That's not how a computer works. The computer is stupid, no matter what. Okay? We already said that data science more or less is everywhere, so maybe it changes name from time to time because marketing and human resources like to change name to things to make it appear new. And this is basically your kind of background, as we already discussed, if you want to be a perfect data scientist. Okay? We need to know about machine learning, statistics, information theory. You will need to know your business domain. You need to know how a database works and stuff like that. So now let's grab a coffee, and then we will start talking a bit more practically about how it looks at a high level of abstraction doing these sort of things.